Hello everyone. In this video we are going to solve the problem number 1.62 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. A small body is launched up an inclined plane which is making an angle of 15 degree with the horizontal. So let us say this is the inclined plane which is making an angle of 15 degree with the horizontal, and a small body, let us say this one, and it is launched up the inclined plane, and it is asking to find the coefficient of friction. Let us denote it by mu, and it is saying that time of ascent is equal to 2 times less than the time of descent. So basically when this particular body is going in the upward direction, then the time taken by this particular ball is given as TA, that is the time of ascent, and when the ball is coming in the downward direction, then the time taken by this particular body is given as TD, that is the time of descent. Okay, so let us first say that the body is launched with the velocity of u. Okay, let us first draw the free body diagram of this particular body. So let us say this is the small body which is on the inclined plane which is making an angle of 15 degree. If we denote the forces in this particular small body, then there will be the gravitational force mg in the downward direction, and as in the inclined plane, so it will have the normal reaction from the inclined plane in this particular direction, and it is having the velocity in the upward direction. So this is the direction of velocity u. So we know that the friction is acting in the opposite direction of the relative velocity. If we talk about with respect to ground, here the relative velocity and the absolute velocity both are same. So that's why we will have the friction in the opposite direction of this velocity, and that we can write it as mu times n, where mu is the coefficient of friction. Now we are having the two direction, one is the normal direction and another is the tangential direction which is along the inclined plane. So let us take the component of this gravitational force in the normal and tangential direction. So one component will be mg into cos of alpha, because if this particular angle, let us denote it by alpha, then this particular angle will be 90 minus alpha and this angle will be alpha. So that's why this component is mg cos alpha, and the component in the tangential direction will be mg into sine alpha. As we don't have any acceleration in the normal direction, so let us balance the force in the normal direction. So we can write n is equal to mg into cos alpha, and if we write the forces in the tangential direction, and let us say the acceleration is in this particular direction, so we can write the net force is equal to mass into acceleration. Okay, so the force is in this particular direction, so we can write mg sine alpha minus of mg sine alpha, because it is in the opposite direction of the acceleration, minus mu times n, and n we have found out as mg cos alpha is equal to mass into acceleration. So acceleration here we can find it as g sine alpha plus mu g cos alpha. So we have got it as negative because we have assumed that the acceleration is in this particular direction, but in actual the acceleration will be in this particular direction. Okay, so this is the acceleration we have got, and it has launched with the velocity of u. So and it is going from this particular point to, let us say, this particular point, and it has covered the distance L. Okay, and here the final velocity is 0. So if we apply the equation of motion, so we can write final velocity is equal to initial velocity plus a into t. Final velocity is 0, so we can write 0 is equal to u minus g sine alpha plus mu g cos alpha into Ta, which is the time of ascent as it is going in the upward direction. Okay, so from here we can find u is equal to g sine alpha plus mu g cos alpha into Ta. So this is the value of u we have got. Now let us find out the expression of the distance L. So we can write S is equal to ut plus half into a into t square. What is the initial velocity? That is g sine alpha plus mu g cos alpha into Ta times, and the time of ascent is Ta, plus half into a we have found out as minus of g times sine alpha plus mu g cos alpha into Ta whole square. Okay, so from here we have got g sine alpha plus mu g cos alpha into Ta square minus half into g sine alpha plus mu g cos alpha into Ta square. So we got the distance is equal to half g sine alpha plus mu g cos alpha into Ta square. Okay, so this is the expression of distance we got. Now in the second case, when the body is coming down, so in that case the body is coming down. Initially the body will have the velocity of 0, and if we draw the free body diagram of this body, then we will have mg in this particular direction and normal which is perpendicular to the inclined surface. Let us denote it by n, and then as it will have the velocity in this direction after it will move by certain distance. So that's why we will have the friction which is opposite to this particular velocity. So we will have the friction in this direction, that is mu into n, and if we take the component of mg in the normal and the tangential direction, then we can write it as mg into cos alpha and mg sin alpha, similar to what we have done while it was going upward. Okay, so if we balance the equation in the normal direction, then we can write it as n is equal to mg cos alpha, and let us say the acceleration is in this direction, so we can write the net force along the tangential direction is equal to mass into acceleration. So we can write mg sin alpha minus mu times n is mg cos alpha is equal to mass into acceleration. So from here we got acceleration is equal to g sin alpha minus mu g cos alpha, and it is taking the time of td, that is the time of descent while traveling the distance of L. Okay, so we can write L is equal to ut plus half into at square. Initial velocity is equal to 0 for this particular case, so we can write half into g sin alpha minus mu g cos alpha into td square, that is the time of descent. Okay, so this is the value of the distance we got while coming down, and both the distance while ascending and the descending will be same, so we can equate these two distances. Okay, so let us equate these two distances. So we can write half into g sin alpha minus mu g cos alpha into td square, that is equal to half into g sin alpha plus mu g cos alpha into Ta square. And in the problem it is said that Ta is equal to Td by 2, so let us substitute it here. So we will get half into g sin alpha plus mu g cos alpha into TD square by 4. Here TD square will get cancelled, half will get cancelled, and from here we can get 4. If we take 4 to this particular side, so we can write 4g sin alpha minus 4 mu g cos alpha is equal to g sin alpha plus mu g cos alpha. Okay, so we got 3g sin alpha is equal to 5 mu g cos alpha. So g will get cancelled, and we can write mu is equal to 3 by 5 into 10 alpha, and alpha is given as 15 degree in the problem. So we can write mu is equal to 3 by 5 into 10 of 15 degree. And if we find the value of mu, that is equal to 0.16. So this is the value of coefficient of friction we got. I hope the entire procedure is clear. Thank you.